Hey pioneers, and welcome back. We are finally in phase 5, but we won't be doing anything related to that. Today we will start expanding our power grid, and I will be doing nuclear. That's something I wanted to do for a long time now. This will be clean nuclear, and as I still don't have access to Fixonium, we will be doing the uranium power plant, we will be creating the plutonium fuel rods, and we will be sinking them. Later on, we will extend it. So, I already made the factory design, and oh boy, is this scary. I started from this point, choosing how much uranium I wanted. I started by 780, but it was too big. I reduced it to 480, and it's still a lot. This power plant is creating 140 gigawatts, way more than I need. And this is sinking the plutonium fuel rods. If I place the nuclear power plants over here, we would go to 262 gigawatts. That's a lot of power. But well, still, I wanted to make a nuclear power plant, and this was the result. As usual, as I have an objective of automating every single automatable item, there will be some outputs. For example, I will be sending some encased uranium cells to a dimensional depot. I will be sending some uranium fuel rods to a dimensional depot, overflow protected, and some other stuff like packaged nitric acid. That's something I didn't have. And over here we have some more packaged sulfuric acid and packaged water. I never automated packaged water. So yeah, we will be getting a lot of power and some automation of some items. As I've been doing on the last factories, everything will be load balanced here except the first stage. So everything we see here on the left side, the inputs, iron ingots, copper ingots, limestone, copper ore, caterium ore, they won't be necessarily load balanced. Maybe I do. But sometimes the divisions are impossible, and sometimes it doesn't even make sense. Because, for example, iron ingots, they come from my train station that has like 2,000 of them. So if I did this load balancer, and later on I did another factory that required iron ingots, I will have to remove that load balancer and do a new one. So that's why the first stage won't necessarily be load balanced. Maybe I do, depends on the numbers and what I'm dealing with. So, we have this huge factory. How do you start to prevent getting overwhelmed? Well, let's divide it into smaller chunks, smaller objectives, and be doing smaller things. So if we move these 3 machines, we can see that over here, this, whatever that is, it's kind of separated from the rest. So let's start from there. Okay, the first module of the factory has been done. But first, let's appreciate this monument to the rock. I don't know what happened, my brain stopped working. I had to rebuild it like 5 times. It always ended wrong. But well, it's finally done, and it's not like it's that great, but well, it's something. So, all of this crap is new, and where do we start? We start by this part over here. Here we are getting sulfur that's connected to a miner that goes to another factory, so there's no point in load balancing this, because if I build another factory that needs sulfur, it would break everything. Still, these inputs are kind of load balanced, because we have 4 refineries, 3 of them have the same clock, and here we can see that there's a splitter dividing among those 3. And this one is extremely underclocked, so I place a smart splitter sending everything that way so that it gets filled up faster, and then the overflow goes to these 3. Anyway, we will be receiving more sulfur than we need, so this is kind of nonsense. What do we have on the other side? Well, the refinery that's extremely underclocked goes to a packager that's doing our packaged sulfuric acid. This is an output. And it's right next to a packager that's packaging water. So both of these outputs go to this tiny output management, where I send packaged water one side, packaged sulfuric acid the other, and I was lucky that there was a sink right there, so the overflow goes to that sink, and I didn't have to place a new one. What are we doing with the important refineries? We have these 3 refineries with the sulfuric acid that is being sent to these 6 refineries. Oh, and I forgot to mention, there's a lonely constructor doing the empty canisters for those 2. But well, important stuff. These are doing our Caterium ingots with the leached recipe. I had never used leached, so I said, well, let's try it once. The numbers are pretty good actually. Way better than the pure refinery recipes. But well, they need sulfur, which isn't ideal. And another reason I use this is because I wanted packaged sulfuric acid as an output, and I can't take it from anywhere else. Because the only other place where we are using sulfuric acid is right here. And this is a closed loop. All of the water byproduct goes over here, that produces the same amount of sulfuric acid, and this system will never need water. But if I package a tiny amount of sulfuric acid from here, I would have to add a tiny amount of water, and that would make the system more complicated. So I decided not to touch it. So, first time I use one leached recipe, really good to be honest. And we are merging all of those Caterium ingots and sending them to this segment over here that is doing quick-wire, I think. Yes, quick-wire. We have 14 constructors, so this is a 1 to 14 load balancer. From this point onwards, all of the factories load balanced, so I can do smart splitters on anything weird. But well, that's a cool load balancer, and we merge all of our quick wire, and we go to this other module that makes our AI limiters. Now, I only needed, where is it? Because I don't remember. I only needed 6 assemblers. So at first I made the load balancer with 7 assemblers, a load balancer with feedback, but then I realized it wouldn't work, because the input is 737 quick wire, and if you do a load balancer with feedback, there's a point of the belt that goes faster than the input, and here we are extremely close to 780. I didn't do the math, but I was pretty sure that it wouldn't work. So instead of placing 7, I placed 8. I think this should be 8. Yay! And we have, well, a 1 to 8 load balancer on this side. That is pretty straightforward. And the other material is getting load balanced here in the air, which is plastic, that it's an input. So now we have AI limiters, and we got to a weird split. This one over here, we need to take 11.34 one side and 37.8 to the other. So that goes to this segment over here. This is a complex load balancer. I've been explaining them on my last videos, so I decided not to tell you how I made this. But I built it, tested it, and works. So we have this amount, 37.8, that for the time being I don't even know where it goes. And this other 11.34. That this goes to our 8 manufacturers that are doing crystal oscillators. And I have been already connecting the inputs because it's kind of annoying connecting all of them at the end. It's something that I don't enjoy that much because it's also starting to get quite complex. My belt bus is starting to get insane. So the moment I get to a factory input, I connect it. That's why we can see some stuff. Anyway, the machines are not powered, so nothing will start working. I will power everything at the same time. So this was the last part of this segment. We are getting our crystal oscillators. And it's kind of insane, all of these machines, and that's just a tiny part of the nuclear power plant. But well, I'm having fun. So what could we do next? Let me go back to the diagram. We have made this part over here. Oh, this one. Well, I'm still touching those. And I was thinking, let's move it a little bit. This is already done. That we could do this other part over here, because we already have these crystal oscillators, we already have these AI limiters, and all of these end up going to a same manufacturer. And as all of these numbers are balanced, I can make a sushi belt with the crystal oscillators and the electromagnetic control rods, making this only one belt, and the manufacturer will only have, well, instead of 4 inputs, only 3 inputs connected. So that's pretty cool. So we would have to make some concrete, steel pipes, wires, stators, with that electromagnetic control rods, and this belt will be merged to my crystal oscillators that I just made. Let's go. Done with this segment. So let's start breaking it down. We start by these 2 refineries that are making us some concrete, and that concrete gets merged and sent into these 4 foundries, which are making us some steel pipe. One material comes from over here and the other one comes from the top, just to mix things up a little bit. In front of that we have all of these constructors. There are 16, 8 on top and 8 on bottom, and they are doing us our wire. And we can see the load balancer over here. So to simplify logistics, I am merging all of the wire with all of the steel pipes, so we get only one belt, and they get sent to this blueprint over here that I don't know why I can't select it. Yeah, this one. That when I started the Mega Factory, I was placing a lot of them. I stopped doing it because I didn't want to everything look the same, but as we don't have any of those blueprints around, well, we have over there, I decided to use it. It saves a lot of time. These are 12 load balance assemblers that are making us some stators. Now on the inputs over here, I'm separating steel pipe from wire. I don't know if this is necessary. I could maybe just send all of them through one input, but that might bring issue if each material is not spread evenly. So maybe one assembler ends up having a lot of wire and the other one ends up having a lot of steel pipes. I'm not sure if that would happen, but that could happen. So I'm trying to be safe over here. Then the output, our stators, goes to this module over here. We've got 10 assemblers, 5 and 5. One material is being load balanced over here and the other one is on the other side. And this makes us our electromagnetic control rods that need AI limiters, but we had already prepared them. It was this output over here from this load balancer. And finally, all of the electromagnetic control rods are being merged here in the middle, and I'm also merging them with the output of these manufacturers that make the crystal oscillators. So this will be yet another sushi line that currently has crystal oscillators and electromagnetic control rods. This is what we've done so far. All of these machines are for these 2 materials. Sounds kinda silly. So what can we do? Let's continue with the factory. We have just finished this segment over here. We can see that the 2 outputs are the ones I mentioned, electromagnetic control rods and crystal oscillators, and they are merged in a sushi line because they both go to the same module over here. So let's keep on working on that. We also need rotors, and the rotors are crafted over here. So let's do this segment. One thing to note, I almost ran out of copper ingots. The ones that come in my train station, I think I have 100 available or less. So I'm doing the rotors only from iron. That, yes, it consumes a lot of iron, but it's good having only one input. No steel, no copper. And I also have plenty of iron ingots. I've never used all of them. So this should be easy to do. Let's go. And I managed to squeeze all of these machines in the gap I had, and it ends up looking pretty cool. So we have 4 constructors over here. They are doing our steel pipes. And we have 12, I think. Yes, 12 constructors on this other side. And they are doing our iron wire. And then they get taken to these 8 assemblers. Some materials are being load balanced here on the top. The others on ground level. And all of this ends up giving us our rotors that I'm merging them to the output line of the manufacturers that are doing crystal oscillators, and later on they are merged to the electromagnetic control rods. From this point onwards I had to increase the belt speed because we already have more than one MK1 of goodies. So what can we do next? We have finished this part. Let's move it to the done part. And these are our 3 materials that we have done. So, these are 2 different things. Let's do this module over here. That it's basically doing a circuit boards and aluminum casing that needs to be sent to 3 separate ways. This is going to be a fun load balancer to make. But well, let's take it one step at a time. Let's first do our circuit boards and our aluminum casing. And this is going to be annoying because I have this amount of aluminum ingots, but the factory produces 4 belts of 620, I think. So I might have to rearrange the output rate of my aluminum factory. Well, we'll see. And the factory keeps on growing. We have a first stage with 12 refineries, yes, that are doing our initial copper ingots. And then all of those copper ingots get merged this way and go to that tiny load balancer. We need to send 362.76 to one side and 72.55 to the other. I know the numbers sound terrible, but it's actually a really easy load balancer. You have to divide the volt into 6, take 1 to one side and 5 to the other. So I don't know, maybe I got lucky. So the belts divided by 6 go to these other 4 refineries that are going to be doing our copper sheets. And then those copper sheets are taken to these assemblers that are doing circuit boards. We have one material load balanced this way and the other one load balanced higher. I do that to avoid clipping over here. And this is actually a compact lift. But if you put all of the lifts from the machine and pointing at the same place, they end up clipping, and I don't like that. So silica connection is already done. And the rest of the copper ingots go this way to this module over here that's doing the aluminum casing. I actually needed 5 assemblers and I initially built it, but what's the thing? One of these inputs is aluminum ingots that come, well, from a factory that produces even more. And if I place 5, I would have to make a load balancer with feedback. And a load balancer with feedback doesn't work if you're sending more materials than... I mean, it would work, but it would look awful. So I decided, well, let's add one more machine so that this load balancer looks better. And well, that's all for now. So let's see what else can we do. We have just finished this over here. And I'm assuming that we could do this line. And that would be around half of the power plant. Well, the nuclear reactors will take a lot of space and time. But well, let's do this line over here. Oh, and one thing I forgot to mention, the water, for the time being, it's all coming from the same pipe. But I've checked how much water it is, and currently is 444. So I probably won't add more machines to this pipe. You could technically take 600, but the closer you are to a full capacity MK2 pipe, the harder it is to have everything working at 100%. Having some space helps us, so if there's a little bit of clogging, a little bit of backflow, it can later compensate by sending more. Right now we are around 75% of use, and I think I'll leave it there, and we'll have to bring another pipe from the desert. But well, let's continue. We are done with this tiny segment. We've got a smelter doing caterium ingots. That goes to an assembler that does quick wire, to an assembler that does the AI limiters. And then we move to the other side of the factory because I had over here the caterium ore and the copper sheets, but the rubber and quartz crystals are on the other side. So I moved it with this belt, because I'd rather not touch the belt buses, they are completely packed. And we are going over here to these two manufacturers that are making the crystal oscillators. Now, I made a terrible mistake, but a really, really bad one, and it's killing me. So turns out, we just finished this part, and we had previously done this one. So I said, well, let's maybe add this manufacturer. And I was checking, we need 98.93 rubber. And I currently have 42 available. I screwed up the factory design. I checked that I had everything I was putting as an input, but apparently I didn't have enough rubber. And rubber and plastic are the thing that I hate the most doing in this game, because I usually with oil try to use the whole node, and if you take good recipes and you start doubling, it ends up being a huge factory, even if you use only 300 oil. So I don't know what, well, I'm guessing I will have to do a plastic and rubber factory, or I could, I don't know, if I use bad recipes, but still I would have 98 heavy oil residue. I don't know. I'll have to think about it. I didn't sign up for this. I didn't want to make rubber. I should have chosen different recipes, but I mean, this doesn't make any difference. I would have to erase all of this module. Nah, I'm not touching that. It's already built. So, well, trouble ahead. I need to think what we are going to do. I'm guessing rubber. I mean, you can't escape that, or start over. Why do I have a spreadsheet if I do these silly mistakes? I'm frustrated right now. But well, the factory is looking good. A lot of progress. And guess I had to do a factory before I finish this one. That's going to be annoying. I'll have to think about it. Okay, got a plan. That it's not that good, I don't love it, but it's something. We have two normal nodes over here that gives us 300, and I had already prepared something for taking pipes that takes them up to this point. I would still have to carry it through my whole factory to the place where I'm working, but well, 300 is not that bad. So I decided I won't do it efficiently. I will use the bad base recipe. So I will be turning all of this oil into rubber. No need for plastic because I still have plenty of plastic. I have 159, 29 and 68 from 3 different factories. Oh, and another 58. Yeah, I've got a lot of plastic. So we will be turning it all into rubber. That gives us the 98 I needed and an extra 101. And then the heavy oil residue, I will be doing petroleum coke. That this is something I had never automated, so a small amount will go to a dimensional depot. And with the rest, there's some phase 5 stuff that we can make. So I will be doing diamonds. I don't know if this is a good way of doing diamonds, but it wasn't the objective. I just want to use the petroleum coke for something. So a tiny amount of those diamonds will go as an output, because I think they aren't needed to build anything. And most of them will be turned into time crystals that are needed for MK6 builds. Anyway, 11.52, I think it's too little. When I'm automating materials needed for builds, I usually want 20 or 30 because I use a lot. But well, it's a plan and it doesn't increase the size of the factory too much. I'm still frustrated, but well, that's what you get. So now the factory got bigger. That's like 1 week more of work. So we start by extracting some slimy oil. This one over here is new. We already had that one and that one. And I already had this cute little tower to carry it. Then we carry that oil through pipes using our rail pillars This is the new pipe. As we are carrying 300, I'm using an MK2 pipe, so it's at half capacity. And these ones were carrying 150, they are in an MK1, they are at half capacity. So we shouldn't have any fluid dynamic issues, I hope. And once we get to the Mega Factory, we raise the pipe, carry it through the belt bus, and now it has a new staff to carry, a new pipe, all the way back to the end of our factory where we are working. And all of this is the new module I had to place. So as usual, I'm using the water tower technique, and we have over here 6 refineries. That are 5. I don't know why I selected 6. 5 refineries. These create the rubber that we actually need. And we have 6 refineries on the other side that will be making the extra rubber for the future. Now, on the other side, this is a complete exaggeration, but I want to avoid fluid dynamic issues. And what's the deal? We have to merge 11 pipes into one, and that can be tricky. So what I did is, with pumps, I raised each of these pipes of heavy oil residue way higher, and then they all get into this horizontal pipe. So the idea is that, for example, the heavy oil residue that's coming through this way won't ever try to climb that way, because they have a lower place to go. So all of this heavy oil residue will drain into this other horizontal pipe that has the refineries that are doing our petroleum coke. I hope there are not fluid dynamic issues, but who knows, we'll see. So on the other side, we are merging all of our petroleum coke, and then we go to this cool load balancer. I figured a new way of doing it. I like how they look, and they are actually easier to build, because we were going to work with 590 and 10 we were going to send to a dimensional depot. So let's, for the time being, focus on the 590. It goes to one particular accelerator that's doing our diamonds. The diamonds go to another cool load balancer, because again, we were going to store a small amount, 1.54, and 23 we were going to use for a later stage. So the 23 go to these 2 converters, the first ones I placed since I'm playing this game, which will be doing the time crystals. So there's no power over here. The time crystals get merged with the diamonds we are not using. All of this way, which also gets merged with the petroleum coke that we are not using, and go to this new output management that will spread petroleum coke, time crystal, and diamonds. And the overflow, I'm taking it this way, and right now I'm merging it with all of the rubber that we are currently not using. If in the future I want to use it, I will have to place a smart splitter over here and take a little bit. And all of this goes to a sink that was nearby, so I didn't have to place a new sink. Now on the other side, over here we have the rubber that we actually needed, and this rubber goes this way with a huge bolt that's flying because magic to these 3 manufacturers I placed. These ones are also new and are doing our radio control units. And they have 4 inputs because, for example, over here we were doing aluminum casing. This aluminum casing feeds 3 different modules. So again, I needed to do another load balancer. And the ones that we need for this stage are 197.87, and the rest are 346, that for the time being I don't even know what they are for, but I know that they are there. Then another input is our circuit boards, that we were already doing them here. So they go to another input of the manufacturer. And the last input are our crystal oscillators that come from those 2. So yes, this is starting to get a little bit messy, but I think it's correct. We'll see when I turn it on. And as a side effect of playing with oil, I don't know why, because it doesn't make any sense, but it made me think, and I realized that we are missing another thing on the factory. Because I didn't design it that well. What's the deal? I still never automated nuke novelisks because I never worked with radiation, and I thought this is the occasion to do it. I won't do it at a later stage. So I had to add even more machines. So I'm adding machines to the diagram at the same rate that I'm placing machines in real life. So this seems to be a project that will never end. But well, over here we were sending 6 encased uranium cells to a dimensional depot. So I changed that, and we will be sending only 1, and the other 5 will go to this new module over here. That, lucky for me, it's small. I could have done the black powder and the smokeless powder, but doing the smokeless powder meant less time crystals, and my weapon factory had an extra 5 black powder and 5 smokeless powder. So I will be taking half of that to this factory. Another weird belt, but I didn't want to add more machines. And then yeah, we have to do some AI limiters and the quick wire. I can load balance it from this assembler that's over there. So the factory diagram keeps on growing. And with that, I think that we are going to be calling it a day. The burnout is real. All that we see over here is new, and we are maybe halfway through. It's insane. If we check the map, from this point onwards, all of this that we see is part of the nuclear power plant. It's like 1/3 or 1/4 of my whole mega factory, and we are not even halfway through. When I finish this, it will be maybe half of my mega factory, just a nuclear power plant. So takeaways I can give right now, without even being close to finishing the project, is that nuclear power is really interesting, it's challenging, and you should do it if you're looking for something interesting or something challenging. If your sole purpose is having more power, you should never go nuclear. Just do rocket fuel, you place some blenders, speed on them, and you have a lot of gigawatts of power. This is insane. But well, I'm kind of loving it. I don't know what will happen when I turn this on. There are a lot of places where I could have made a mistake. But well, it's looking pretty dope, so I'm excited about this. But a lot of work. I'm decorating this. Oh, it's going to take ages. But well, I'm having fun. I hope you guys enjoyed this video, and I'll see you on the next one.